Hello everybody, here to show you some new updates to the o2v converter tool. What I've added now is a vertex optimization algorithm. I had to rewrite some of the underlying structures to facilitate this, and also added in some color thresholding algorithms to also facilitate vertex reduction. So let me jump right into it and give you a demonstration. I'll use some familiar models. Let's put them a core parrot, voxel converter script. I've also added in a loop of code now to try and automatically find the armature target, so you don't have to manually drag the target onto here. It should find it. I haven't had any problems with it, but you can still manually assign it if there is a problem. It'll only automatically look for it when this is not been set. So let's generate some debug cubes. Okay, I'm going to just build the model as it is without applying any color thresholding algorithms. There's already vertex reduction here compared to the old algorithm, as there would be similar colors based on the selections from the UV map and the merging of vertices in between voxels, which it previously never did. So the vertex count is 2.8. Let's just look at that. Okay, so I'll bring up the debug window, and yeah, you'll see the color thresholding settings. They're just beneath all the old color settings. There's U channel max 12, saturation channel max 5, lightness channel max 5, and luma channel max. Luma is the grayscale. So I'll leave it on the default settings to say apply color thresholding. There were some changes there. I don't know if you'd see it in the video, but let's just hit generate final. We'll see we're down to 2.1. There's about 700 vertices reduced now, purely on color thresholding optimizations. That and above what it's already been optimized to do. Okay, great. Let me try it on another model. I'll also take something I previously used before, the dog. We'll say generate new. Again, you can see I did not assign the armature. It's going to just look for it on its own. Okay, so there's our model. Let's generate a final first without doing the thresholding, and look what our vertex count is. Okay, it's on 7.6. You'll see there are a lot of variations of this brown color that it found in the UV map, and that will be the cause of that. That is a reduction. Originally the model was about 10K before these changes, as it was like this, so we're down by about 3,000 already just as it is. But let's do some color thresholding. Again, I'll just leave it on the default settings, say apply thresholding, build the model again. Okay, we're down to 6.7, from 7.6 to 6.7. That's close to 1,000 vertices that have been removed, and you'll see there's many variations of colors. I don't know if you can see in the video, have been reduced somewhat, but obviously that's just on the default settings. You can try and tweak it further. It's difficult to say where the tweaks must happen. It depends how the color variations in the model were selected, if there were more saturation levels or if there were more lightness levels within the colors, or more U channels. But I've done some previous tests on this. I'll just take the saturation levels down by 2, and I'll take the U levels down to 6 instead of 12. The U channels, just that you should know, it works from 0 to 360, you people that don't know. So any multiples like 3 and 6, 12, 24, 36, etc. are the numbers that are required. You can put other numbers in, it won't break, but it won't try and split up the color channels evenly across the U spectrum. Let's apply this color thresholding. There were some reductions that I could see visually. So generate final. Test our model, and we're down to 5.7. You can see we still have the colors on his nose, whatever it's selected by the eyes and by the feet there. But on the body now, all those many variations that were there in the previous model causing the 7.6 have been reduced, and it's down to 5.7. To show you, let me show you the AO. When I rewrote the underlying structure for the optimization of the vertices, I realized there was room to improve the AO calculations. The previous AO calculation had a problem where it shared some data. So if there was AO, for instance, let me just pause this animation altogether. If there was AO in this corner here, for instance, let me zoom right up, it would bleed out onto the vertex on top here, and you would get some banding of black here where it was totally not needed. And for instance, say on those two vertices over here, you'd get the same thing happening here. That has been fixed now. Let me turn this on really strong and see if I look at this from the side. You can look in any of those crevices there, and in the legs, and in there, that it doesn't bleed out onto these vertices here any longer. Look on the back there as well. So that looks way better, and I'm happy to have got it done. Okay, let me get out of here. Two other features I added just while I was doing the color settings. At the debug window. Instead of, you could always cache the color and apply cache colors and group select or single select, and you could do new color, but I added in tinting of colors. So you can select a whole bunch of vertices and tint them. Let's just choose a blue color here. I'll say apply tint. Obviously that applies a tint over and above what the underlying color was, so you will get quite a bit of a dark color there. For tinting to really work nicely, you want to grayscale the pixels so that you're just left with the luma value, and that's what this button is here for. So for instance, let me just select those and say apply grayscaling. And there you can see those pixels are now grayscale, so they still have their luma value for those that were light and those that were darker. And if you apply tint over grayscale pixels, it will appear as it should be, with a better color, not dark like you see there over those original, and you can still see the variations there. Yeah, so that's it. Thanks.